This is the answer key to the Module 9.1 Exponents Desmos review questions. Which of the following applies to the quotient of powers property? Select all that apply. If you look at quotient of powers property, it states that the bases have to be the same. So when I look at just that part of the property, I notice the first one, the bases are different. Second one, the bases are the same. Third, different. Fourth, same. And the fifth, the bases are the same. Use one of the answers you selected from slide 1 and prove how it uses quotient of powers property. So when I looked at that, I decided to use 9 to the 7th power over 9 to the 3rd. So I wrote that over here. Now on top, I did not use the property. What I did is I actually wrote it out. I wrote 9 7 times as a factor. 9 cubed would be 9 3 times as a factor. And then I canceled the one 9 on top, one 9 on the bottom, another 9 on top, another 9 on the bottom. So there were 3 9s on top. I was able to cancel with the 3 9s on the bottom. And then what's left is right here, 9 times 9 times 9 times 9, which is 9 to the 4th. Now the quotient of powers property states that when the bases are the same, you could subtract the exponent in the numerator minus the exponent in the denominator. What they're really saying is you could take away 3 of the 9s from the 7. And that's exactly what I did here. I took 3 9s from the bottom and 3 9s on top. So when you subtract 7 minus 3, it equals 4. So if you were to solve this, you don't actually have to write it out. You know if the bases are the same, you could just subtract them, and the answer is 9 to the 4th. Now, if it asks you to solve it, then you'd actually solve 9 times 9 times 9 times 9. The square tile shown has a side length of 10.5 inches. What power can you write to represent the area of the tile? Write the power and then find the area of the square. So for a square, it's side times side or length times width. So since it's a square, both sides are the same, 10.5 times 10.5. So to write it as a power, I'd write 10.5 to the second power, 10.5 squared. Now it asks you to find the area, so I acted like I multiplied whole numbers, 105 times 105. Then I put the decimal back in and then put it in the answer, in the product. So the answer is 110.25 or 110 and 25 hundredths. Now here, if you look, it's inch times inch. So I multiplied inch twice. It's square inches. Don't forget area is always square inches. So here's the power. Here's the final answer. Ariane is saving for a video game. On the first day, Ariane saves $2 in the piggy bank. Each day after that, Ariane doubles the numbers of dollars that was saved on the previous days. How many dollars does Ariane save on the sixth day? So a pattern that I want you to notice. Day 1, Ariane saved $2. Day 2 doubled that amount, which is 2 times 2, if you doubled it. And day 3, you would take the amount from the previous day and then double that. So 2 times 2 is 4, 4 times 2 is 8. So you'd always write the amount from before and then double whatever that is. What I want you to realize is that the number of day of savings is how many 2's will be listed. So following this pattern, by day 6, it would be you'd have 6 2's or 2 to the 6th power. That's how much money Ariane would be saving on day 6, which is $64. So if it asks, what about day N, then I wouldn't or if it was day 7, then I know I'm going to have 7 2's. Now, what if it asks you, what about day N? With that, all we know is whatever the day number N represents, that's how many 2's we would have. So then if I were to write that question, my answer would be 2 to the nth power dollars. And then N would be any integer they would give us. So if N equaled 3, it'd be 2 to the 3rd. If N equaled 5 or day 5, 2 to the 5th, like that. So sometimes you may see where they ask, what about day N? A certain colony of bacteria triples in length every 10 minutes. Its length is now 1 millimeter. How long will it be in 40 minutes? Write it as a power and solve. So when they say that right now it's at 1 millimeter, but every 10 minutes it'll triple, what they're saying is that right now means at 0 minutes. At this moment, it's at 1. Now we're going to start looking at it. In 10 minutes, it'll triple, which is at 3. 1 times 3 is 3. At 20 minutes, it'll triple from this amount, 3 times 3, like that. 30 would be 3 times 3 times 3, and then 40 would be 3 times 3 times 3 times 3. So as a power, it would be 3 to the 4th millimeters. And in solving this, now if you were to solve this, what I would do is 3 times 3 is 9. This 3 times 3 is 9. And then just do 9 times 9, 81. I would pair them up and then solve it. Which power can you write to represent the volume of the cube shown? Write the power as an expression with a base and an exponent, and then find the volume of the cube. So if you remember, volume is the amount of space on the inside. So to figure out how much space is inside this cube, we're going to have to do length times width times height. So length is 1/3. It's a cube, so all sides are squares. It means all dimensions are the same. So length is 1/3, width is 1/3, height is 1/3. And then to rewrite that, I'd write 1/3 to the 3rd power. But remember, if you're repeating a fraction, you have to protect the fraction in parentheses to make sure that 1/3 is written 3 times. Okay? And then when I solved it, I just used the information I had on top to solve this. 1 times 1 times 1 equals 1. 3 times 3 is 9. 9 times 3 is 27. And then because we did inch times inch times inch, that's inch to the 3rd power, or cubic inches. So 1/27 cubic inches. Instead of writing the label the way I wrote it, you could write it like this: cubic inches. Cubic inches could be abbreviated with CU, period, inches, period. Or write out the whole label cubic inches. Any of these 3 ways to write your label is correct, but you must have cubic inches. And again, that 3 represents cubic. Write a power represented with a positive base and a positive exponent whose value is less than the base. So when you think about it, that means that your base has to be a decimal or fraction, but be careful what kind, like any decimal fraction less than 1. So let's take a look. Any fraction decimal less than 1. If you have one that's more than 1, it will be greater than the base. So let's say like when I had 0.3 squared, because remember, fraction means you're taking part of the amount. So when I'm taking part of an amount, if the number is more than 1, then you're creating more of that greater than that number. When it's a partial of the amount, that's why it'll be less than the base. So 0.3 squared, 0.3 times 0.3, 3 times 3 is 9, move the decimal twice to the left. 9/100 is less than the base, which is 3/10. I could have used 2/5 squared. 2/5 times 2/5 would be 4/25, and 4/25 is less than 2/5. It could be any exponent that you could use. Some numbers can be written as powers of different bases. So for example, 81, I could write it as 9 squared. 9 times 9 is 81. And then 9s could be changed to 3 times 3. So I realized that 3 to the 4th also equals 81. So those are 2 different powers that equal 81. Write the number 64 using 3 different bases. Do not use one as a base. So I know 64 could be 8 times 8, makes 64. So I could write it as 8 squared. Then I realized 8 could be rewritten as 4 times 2. The other 8 could be written as 4 times 2. Now, what I noticed this right here equals 64, but I realized that I could pair those 2's up. 2 times 2 is 4. So actually, 4 to the third power equals 64. And then I realized that my 4's could equal 2's, and then down here, this equals 64. So 2 to the 6th power equals 64, and those are my 3 different powers that equal 64. Actually, it should say do not use 1 as an exponent. How does the quotient of powers property prove that the answer to an exponent of 0 equals 1? Show an example. Now, the quotient of powers property, remember, states that if the bases are the same, you can subtract the exponents from each other, the numerator minus the denominator. So 5 to the 3 minus 3 equals 5 to the 0, which equals 1. The 3 5's in numerator cancel out the 3 5's in denominator. So look at my example. When your bases are the same, I'm able to just subtract the numerators, 3 minus 3, because they cancel each other out, which means there are 0 5's left, which equals 1. So if you look here, all the 3 5's on top cancel the 3 5's on the bottom, so there's nothing left except for 1. Feel free to try any of these again if needed.